Yes, I'm audible.
Good afternoon.
Yes.
Good afternoon.
Yes, good evening.
Yes.
Yeah, let me start. Basic introduce yourself.
Sir, I am Orkumanna. I am from East Midnapur, West Bengal. I have done my schooling from native school, Vivekananda Mission Ashram Shiksha, and then I have done my BSc from Belur Ramakrishna Mission. And after that, I went for my master to IIT-BOMBAY. And my hobby is to motivate local students and to free teaching of them. And also, my hobby is to going to gym.
Yes, good. Last day we have discussed analytical chemistry, chromatography. Yes.
Yes.
Basic.
Yes.
How many topic cover in last day?
Sir, you have at first asked from oxidometry, reactometry reaction, and that is the titration portion from, and then from chromatography you have started some question of partition chromatography, paper chromatography you have asked, and at last you have asked, I think, HPCL, HPLC,
Adjacent,
and then time.
ion exchange, exclusion, electrochromatography. This one is completed.
Yes, sir. Yes, sir. Yes, sir. You have.
Yeah, next one is HPLC chromatography. Yes, what the main application of HPLC?
Sir, there are various applications of HPLC. From HPLC, we can detect, sir, very minute amount of that is parts per trillion amount of materials also. So if there is anything impure in the water sample or impurity in the something food drinks or something that is available in the market, if there is something impurity, we can detect easily because it have high power of to detect parts per trillion level of materials. So if there is any contaminant present in water source, that is like cadmium, mercury, or other things, so we can also detect them. So in this way, for the environmental analysis, it is useful. Also in case of food analysis, like if there is some cold drinks, if there is some impure elements are present, so we can detect from that also. And also from in the pharmaceuticals, if there is anything else which is harmful, it is present, so we can detect also them. And also in the organic chemistry, it is useful in high level.
How many types of HPLC?
Sir, HPLC are various types, like common four types of HPLC: normal HPLC, reverse phase HPLC, and also ion exchange HPLC, and size exclusion HPLC. Normal phase HPLC, reverse phase HPLC, size exclusion, and ion exchange.
Stationary phase and mobile phase. Yes. What the difference of these
Yes,
one
sir.
in HPLC?
Sir, okay. Sir, in the normal phase HPLC, stationary phase is polar, and mobile phase is non-polar. But in reverse phase HPLC, the stationary phase is non-polar, and stationary phase is non-polar, and the mobile phase is polar. And in ion exchange, so HPLC we use for cation exchange. If it is need for cation exchange, we will vary the anion in there in the part of this. But if we want that to anion exchange, then we will use some stationary phase which will be cation in there, which have cation binding ability. So and in the reverse and in the size exclusion HPLC, we mainly use we actually it is mainly dependent on the porous size of the material. So we vary the porous size of the stationary phase, and that's why it exchange ions in the basis of their size. So in this way, we can use the different stationary phase we can use for different functions of HPLC.
Yes, what the example of next one is ion exchange chromatography. Yes, first,
Yes.
what some basic question. Any drawback limitation of HPLC?
Sir, drawback means it is less accurate than gas chromatography, firstly, and then it is expensive, and also it is more time is needed for it, and uh, more time is needed, and it is also expensive also. So gas chromatography is more preferable than HPLC.
Yes, next move on. The next is ion exchange chromatography. What the main application of ion exchange chromatography?
Sir, to detect amino acid, to detect protein sample, and of the for water purification also they are useful. For nucleic acid separation and exchange chromatography are useful, and for detection of any vitamins or any biological compounds, ion exchange means in which the compounds are ionic. For that, ion exchange chromatography are most useful. So if it may be cation or anion. So based on the dependence of the materials, that is the stationary phase, if it is cationic or anionic, we detect it.
Yes. Yes, what are the example of common ion exchanger resin?
Sir, example of?
Common ion exchanger resin.
Okay, sir. Sir, actually there is a long aliphatic group, and after that there is SO4 minus or NH4 plus. So for SO4 minus can vary the different type of cation, and if there is NH4 plus, then it can vary different type of anion. Or maybe carboxylate also present for a cation exchanger. Carboxylate or sulfate is present for cation exchanger, and ammonium is present for anion exchange.
Yeah, next one is what is exclusion chromatography? What the main application of exclusion chromatography? What the uses of
Sir,
exclusion chromatography in analytical chemistry? Describe.
Sir, exclusion chromatography is useful for variation of different size of particle. So if there is a large size particle, it needs less time to go through the column, because it will not go through the porous of the material. So it will come fast. So if there is particle size is large, so it will come fast, and if particle size is small, it will take more time to come into the sample. So basic on this, or based on the particle size, actually exchange means size exclusion chromatography offers.
Yes.
Sir, and
Next.
ion exchange
Yes. Yes. Carry on.
and size exclusion chromatography also useful for detect various type of polymer actually. So polymer size, if there is different type of polymer size, so it will if large size of polymer is there, it will come fast, and if small size of polymer, it will come after that. So based on actually for analysis of polymer, actually we use size exclusion chromatography, because when we are creating polymers, so it will create in various type. We have no power to control that the size of polymer actually. So there will be some impurity, that if we want to make a chain of 20 amino acid polymer, or like other things, that is polyvinyl chloride or other things, that if we want to make a 20 of chain length chain, but it may also create that 19 or 17 member chain or 5-member chain. So to separate them, we use that size exclusion chromatography actually to separate various size of polymers.
Yes, good. Next one, what is supercritical flood chromatography? What the main application of flood, supercritical flood chromatography?
Supercritical flat
Flood.
chromatography. Sir, one second. My actually headphone is not working. Headphone coming out.
Yes, I am audible.
Sir.
I am audible to you.
Yes, sir. You are audible, but not sound is not coming from my head. Sir, just give me 1 second. Sorry. Yes, sir. Hello, sir.
Yes, carry on.
Yes, sir. Sir, please repeat the question.
What is supercritical flood chromatography? What the main application of supercritical flood chromatography?
So super pretty flat chromatography mainly it may be paper chromatography or other things or TLC like these things. So flat chromatography is under that criteria. And in the supercritical means that is the stationary and mobile phase both are liquid. I think. I am noting this supercritical flat.
Do you have any idea about this one?
Sir, flat chromatography that is the paper chromatography, and in the paper chromatography mainly we use that stationary and mobile phase both are liquid, and they are on the basis of the solvent polarity or non-polarity, it will molecule will come first and come later. So on the basis of this, we can separate them. So, but
Okay, no problem. Next, move on electrochromatography. What the main application of electrochromatography?
sir, in the electrochromatography, mainly we can separate amino acid by the use of electrochromatography. So in the electrochromatography, we use different cathode and anode, and we change the pH of the materials under of it to electrodes. And by changing the pH, if there is cation amino acid is in cationic form, it will come to the anode, and anionic acid is in the anionic form, it will come to the cathode. So basis on this we can separate different type of amino acid by using electrochromatography. And in the electrochromatography, main use of this is to separate various amino acid or nucleic acid also we can separate by electrochromatography.
Yes. Next one, the part of chromatography is gel filtration.
Yes, sir.
Electrochromatography, how many types of electrochromatography? How many types? Any separation technique in electrochromatography? Do you have any idea?
No, sir, I don't know any type of electrochromatography. Yes, sir. Gel chromatography is also useful for detection of amino acids.
Yes.
Gel chromatography is there to detection of amino acids.
Any other?
Sir, error in gel chromatography. Hello, sir.
Standard gel electrophoresis, capillary electrophoresis.
Sir, please repeat the question.
Other part also in presence in electrochromatography is standard gel electrophoresis and capillary electrophoresis.
Yes, sir. Standard. Yes, sir. Both are useful for detection of amino
Yes.
acid and nucleic acid. And capillary electrophoresis is most modern technique, but gel electrophoresis is less modern. At first, gel electrophoresis was created. After that, capillary electrophoresis is created. So, in the capillary electrophoresis, we can detect the amino acid very fast. But in gel electrophoresis, it takes lots of time.
Any drawback of electrochromatography? Any drawback, disadvantage, limitation?
Sir, gels can melt, or in gel electrophoresis, gel can melt, and there may be heat of diffusion or complexity in the peak may happen. That for in the electrophoresis, there is different type of peak for different type of amino acid. But if two peaks may merge, or there is the heat diffusion may happen, or buffer can deplete.
Yes. What the main uses of capillary electrophoresis? Main uses.
Sir, main use is to detect the amino acid sequence actually. So by it we can detect the amino acid sequence after what sequence is there. And it can be used very fast than gel electrophoresis. From gel electrophoresis we can also do but capillary electrophoresis is fast.
Yes, good. Next, move on. Next section is instrumental method of analysis.
Yes, sir.
Yes, what the main application of instrumental method of analysis?
Sir, by instrumental method, we can easily detect that actually what compound is present, and in know-where technique, we can easily detect that what compound is present. So, but in instrumentation, we can actually finally 100% 100% surety we can tell that this compound is present there. So, instrumental analysis is the final of all the techniques. So like there is IR, NMR, or UV, fluorescence spectroscopy, this technique, or ICP-MS, flame spectroscopy there we use there. And from that we can easily detect qualitatively and also in some cases quantitatively, like flame spectroscopy, quantitatively we can detect the elements present in any sample.
Yes. Next one, the basic point is type. What is thermoanalytical method? What the main application of thermoanalytical method?
Sir, I have not actually read thermogravimetry portion. Sir, in also for the mains also I have not.
Okay.
So I have to read this portion thermogravimetry.
So
Sir, I
have
have
you
not read
read? Yes. Okay, no problem. This one left is thermo and mechanical, volumetry, vectrometry, polymetry, polarography. Yes. Next we will discuss. No problem. What about the spectroscopy method of analysis? Have you studied? Have you read?
Sir,
What
what?
about spectroscopic method of analysis? like atomic absorption spectroscopy, atomic emission spectroscopy, ICP.
Sir, in ICP, actually, we use 4,000 to 6,000 degrees centigrade temperature, and by which any type of material will be vaporized, and from this we will send it to the flame, and the flame after the flame there will be a detector. So the absorption what happens or the emission what happens. So you will detect the absorption or emission peak, and there is absorption or emission is different for different kind of materials. So by the known type of sample, we can easily detect the what is the absorption or emission peak, and then comparing it with the unknown sample, we can easily say that which type of materials is present. So actually, by absorption and emission peak are specific for specific materials. So by the detector, we can easily detect that which type of peak is present there. So from that, we can easily tell that which materials is present. And there is various different type of temperature we use there. In ICP-MS, we use 4,000 to 6,000 degrees centigrade temperature, and normal absorption or emission peak is little bit different. That is 2,000 to 3,000 degrees centigrade temperature.
Yes, good. Next, move on. The part first is atomic absorption spectroscopy. What the main application of atomic absorption spectroscopy?
Sir, atomic absorption spectroscopy are also also is under the flame spectroscopy. So they can be used for clinic and industry, or they can be used for detection of any impurity in any type of sample present. That is that is in water sample or soil sample, any type of compound is present or not. In food industry, if there is any impurity present in food, like cadmium, mercury, if there is present in food, some poisonous elements, other poisonous element is present, so we can detect them easily. Or some cement industry also for sodium, potassium, calcium content, if there is present, so we can use this. Mainly, it is used for alkali and alkaline earth metal. Absorption and emission peak is good for alkali and alkaline earth metal. So we can also check the soil quality also, if there is present sufficient amount of potassium, sodium, calcium is present or not. And also in water, purified water, if there is not present in sufficient amount of sodium or potassium, we can easily get into it by other side. And also some detection of serum or plasma of urine, if there is sufficient amount of sodium, alkali and alkaline earth metal like sodium, potassium, calcium is present or not. So we can also detect it.
Yes. Next one is atomic emission spectroscopy. What the main application of atomic emission spectroscopy?
Sir, atomic absorption and emission, both spectroscopy are useful for same purpose.
Same purpose. Any disadvantage of atomic absorption and emission? Disadvantage.
Sir, disadvantage is there in the atomic emission spectroscopy, but atomic absorption spectroscopy is far good than atomic emission spectroscopy. Because in case of atomic absorption spectroscopy, we use a source outside of that. But in emission spectroscopy, there is what happens, the absorption and emission both are happen by the flame temperature. So in the absorption spectroscopy, there is not some in the absorption spectroscopy, we using the other source of light, we actually absorption happens. But in emission spectroscopy, there is the by the it absorbed by the flame light, and by the emit by also flame light. So the absorption and emission peaks are mixed in the emission spectroscopy. So in emission spectroscopy, we cannot detect the actually cannot get the right answer. So for that, atomic absorption spectroscopy is far good than atomic emission spectroscopy. So to recover the disadvantage of atomic emission spectroscopy, we actually made atomic absorption spectroscopy, and in atomic absorption spectroscopy is different because there we use hollow cathode lamp or EDL from the other side. So it is external source we use for the absorption.
Next one, what the main difference of ICP, atomic emission spectroscopy, and atomic absorption spectroscopy?
Sir, ICP atomic, अच्छा.
ICP, AES, and AAS.
Sir, ICP atomic absorption spectroscopy also use we means EDL or HCl from the other side. So, but in atomic ICP atomic emission spectroscopy, we have no use of HCl or EDL. So directly that is the compound which is gaseous state by the heat of 4,000 to 6,000 degrees centigrade of ICP. So it will emit on its own, and then the peak what it will generate will the detector will detect that. So, but in ICP atomic absorption spectroscopy, we use externally. We can use we have to use externally some source. So some source which will actually make it to absorb. So uh, so there is ICP inductively coupled plasma is only there for the purpose to make it in the gaseous state. And after that, the source of light will go to it to absorb the peak, and then it will give us absorption peak. So in this way, they are different in their instrumentation differences.
Any drawback limitation of ICP, AES?
Yes, sir. Emission is always atomic emission spectroscopy is always not always the correct answer it gives, but from atomic absorption spectroscopy we get more precise answer. But atomic emission spectroscopy is less actually priceful. But in atomic absorption spectroscopy is precise, much more precise. So in this way they are different.
Yes. Yes, how to work ICP atomic emission spectroscopy? Any mechanism, instrumentation, how to work? Can you describe?
Sir, ICP atomic emission spectroscopy.
Yes.
Sir, first there is RF coil. Sir, in RF coil we use mainly argon gas. So argon gas at first it will be made Ar plus, and Ar plus molecule will collide with other argon molecule. So it will make Ar plus means positive ion in surrounding. So these positive ions when it will collide by the RF coil, that is the electricity we are generating, it will collide and it will create a high temperature like 4,000 to 6,000 degrees centigrade. And when we insert any sample from sample inlet, so it will go at first in the spray chamber, and the spray chamber it will be in the molecular form, means atomic form. It will come and it will be in the molecular form, that is in the vaporized form, and then when it will go to the means inductively coupled plasma, that is ICP, then it will be formed into the atomic state, and then it will the emission will happen from its own, and we will have to use a monochromator So from monochromator, we can give a specific signal. It will go to the detector, and after that, we will record the signal.
Yes. Good. Next, move on ultraviolet and visible spectroscopy. What the main application in spectroscopy method?
Sir, UV and UV ultraviolet visible spectroscopy are used for detection of. Sir, they are actually absorption spectroscopy. So
Yes.
so we can detect any type of sample, that is biological sample or organic sample. We can detect from the UV visible spectroscopy, which we have the specific wavelength region, that is energy gap which matches with the UV visible. So this type of sample we can detect by UV visible spectroscopy.
Yes. What the source of UV source? UV visible
Sir,
spectroscopy. What the source?
uh, hydrogen discharge lamp, deuterium lamp, or xenon discharge lamp. So
Yes. What
they
the
have,
range of UV visible light? Range. What the range UV and visible light?
sir, 180 to 70 nanometer, some 700 nanometer, 180 to 700.
Yes. What the main application of Beer-Lambert law in UV spectroscopy method?
Sir, Beer-Lambert law says that absorption equal to epsilon into C into L. So epsilon C. So by changing the concentration, absorption will be increased, and by changing the length of the cuvette size, also absorption will increase. Because if we increase the length of the cuvette, so there will be more molecule will be there, and if there is more molecule, it will be absorb more absorption, and it is he said that it is a linear relationship with that. So also it is depend on the concentration. So if there is more concentration of molecule, so more absorption will be happening. So like so this type, in this way, uh, actually A equal to epsilon CL is satisfied.
Yes. What the drawback limitation of Beer's law?
Sir, Sir, actually the graph is not straight always. If there is concentration is high, so it can be curved, or in high concentration, the means it does not follow the A equal to epsilon CL. It will curve upward, and also if there is if there because there if there is more type of more concentration, so then all molecules will not absorb the light, and also scattering happens. So if there is scattering happens of light, so all molecules will not absorb the light. So in this way the line is not straight always. Means A equal to epsilon CL each does not follow always.
Yes. Good. Yes. UV spectroscopy is what is electronic transition? And how many type of electronic transition present in UV? Electronic transition.
Okay. How many type of electronic transition I don't get.
Sigma to sigma,
Sir,
pi to pi, n to pi is the type.
okay. Oh, sigma to sigma star, sigma to pi star, pi to sigma star, to delta star also transition happens. Like rhenium complexes RE, or delta bond if there is present. So delta to delta star transition also.
Yes. Which one is allowed and forbidden transition in present in electronic?
Sir, it depends on the Lapate forbidden and spin forbidden rule. For Lapate rule, it said that del L have to plus minus. So if del L is 0 or del L is something other value, so transition will not happen. And changing of spin will have to be 0. So del S must have to be 0 to satisfy the transition. So it is spin selection rule and Laporte selection rule are present to say that any transition is allowed or forbidden.
Yes, what the basic difference of chromophore and oxychrome in UV?
Sir, chromophore, I know that things, but I just forgotten the terms. Sir, chromophore means that the compound which can absorb UV light, and oxychrome means if there is we use some another compound there, so it will basically takes more type of light. I think, sir. I just forgotten the terms, sir. Just forgotten. Sir, chromophore means actually if there is a benzene ring, it is chromophore. But if we add something else with it, it is said to be oxychrome. That is, if we add NO2 group in with benzene ring, so it is said to be oxychrome because it will absorb more UV light.
Yes. Next one is UV spectrum and shift in absorption band. How many type of absorption band present in UV spectrum?
It have a absorption band.
Do you have any idea about red shift? Blue
Yes,
shift,
yes, sir. Red shift and blue shift is there.
hyperchromic,
So,
hypochromic.
bathochromic shift means red shift. So if the energy gap is decreases, so there will be the bathochromic shift. So energy gap is decreases when there is more conjugation is present there. So if more conjugation is present there, then it is the energy gap is less. So the shifting of light to the side of red light. And when there is energy gap is increases, like if we have to use benzene ring with O minus and then we remove the O minus. So now if only benzene, so there will be an energy gap will be increased. So if energy gap will be increased, then it is set to the shift to the blue shift. And if energy gap decrease, it will be the red shift. And red shift is known as bathochromics. And blue shift is known as hypsochromics.
Yes. What are the uses of this shift? Do you have any idea?
Sir, by using this shift, we can tell about the conjugation of molecule. If molecule is highly conjugated or so conjugation, what is the value of conjugation?
Yes, yes,
So,
good. Yes, next day we
and
will
we can,
discuss in the left part of analytical chemistry and the left part of spectroscopy. Yes.
sir, what part?
Left part, chromatography section, instrumental section in analytical chemistry and spectroscopy left part. Left part of spectroscopy and analytical chemistry. Both
Okay.
we will discuss in next day.
Okay, sir.
Okay. A basic question is aniline show blue shift in acidic medium. Why?
Sir, what?
Aniline show blue shift in acidic medium. Why?
Sir, because NH3 plus is there,